Okay, good morning or good afternoon. I am on fire here. Let's continue on. So we are still working on chapter 6, section 1. All right. And now we've moved on to example 6-5. So here, this is from page 320, and I've just tried to copy down the instructions so I don't have to go back and read them out of the book. It says to find the z-values such that the area under the standard normal curve between 0 and a z is exactly 0.2123. Okay, so let us go to our little sketch pad, and you can see I've already sketched out our normal curve. And so what we are going to do here is we're going to just further define the region that it is we're talking about so that we can better conceptualize it. So what this is telling us is that we have some z value over here. We don't know what it is, right? We're going to solve for it. We're going to find it, okay? And what do we want? We want the area between 0 and z, so the shaded in area. We want this to be exactly 0.2123. Got what I was doing for a second. All right, so here is what we're going to do. We're going to do two things kind of differently. So in the past, we had started with a z value and then found the area. And there we just used our table, plugged in the z value, and then found the area in the body of the table. So just to reiterate that, I don't know if you can see that very well. Let's try this again. In the past, when we were finding the area, we started with our z, so we fed in the ones and tenths and then the hundredths, and then found within here that was the area, right? So these are all left areas to the left of our z value here, okay? Then what? Well, in this case, we have the area. So we have this figure and we have its area. We already have that target value. So what we're going to be doing is finding the correct area within the body of this table. And then from there, figuring out what z value goes with that. If we cannot find the exact area, that's okay. We'll just find as close as we can get to it, right? And on this one, you're gonna have to help me out because I'm gonna get it wrong most of the time. I'm just saying that last part about figuring out, is it closer to 7.7357 or 0.7389? Just for the sake of argument, that's going to be where I'm going to stumble. But the rest of it, I'm going to be leading us with striding confidence. All right, so now that being said, we are not going to just simply look for 0.2123, because remember our z table gives us the area from z and everything to the left, and that's not what we want. Our picture is a middle area. So we want actually the z value such that when we subtract away 0.5 exactly, remember that half of it is 0.5, 0.5, all right, we want our left area to be 0.2123 plus 0.5. So we're actually looking for the left area that corresponds to, I'm sorry, we're looking for the z value that has a left area of 0.7123. So just to go back, if we have a z value that has the area, everything to the left of it is 0.7123, so everything to this side is 0.7123, then what would the area between 0 and this z be? that would be exactly 0.7123 minus 0.5, which of course is 0.2123. So that is the value that we're going to be finding within our table over here. Okay. And we're seeing that it's larger than 0.5. So that makes us want to look on the positive Z side of the page. And here I'm going to find as close as I can get to 0.7123, 0.705, 0.73. Okay, too big, so let's back up. Oh, look at that. That is exactly it. So that is the exact area. I don't have to fuss around and see which one it's closer to. I found it exactly. That's perfect. So what's the Z value? The column is 0.06. The row is 0.05. No, sorry, I said that wrong. 0.56. So that is our Z value. The Z value is 0.56. And just so I don't confuse you with that last note, let's get rid of that. Okay? So that was that problem. That was finding a Z value given an area. The opposite, or the backward mapping of our standard, give me a Z value and I'll find you the area kind of problem. All right, so that would be one key idea to keep in mind is at the beginning, distinguish between what type of problem is it? Is it straightforward or are you doing the backward mapping, right? So do they just give you the Z value and say, find me the area? That's straightforward. There you're using the table directly as it is meant to be. Or do they give you the area and say, find me the Z value? Well, if they do that, that is a backward map where we have to use this table, but backward map. So we have to find the output and then find that corresponding input that goes with it. All right, so I'll sign off now for you.